Today we're going to be talking about modeling with quadratic functions. So we've worked a little bit on quadratic functions, finding the vertex and graphing them and so forth. So first off, let's talk about a little bit of vocabulary words that we can associate with quadratics. Now when you hear the word quadratic, we know that that can mean it's a squared term. Okay, so we know a quadratic is something that has the highest power is an x squared term. Okay, we also know that the shape of the graph of a quadratic is a parabola. Now, in word problems, a lot of times when they are talking about a quadratic function or a parabola, they will use the word parabolic path or something parabolic. And so when you see this word, parabolic, don't freak out. It simply means just a quadratic. Okay, so those three terms are similar or almost interchangeable with the word quadratic. And so don't forget when they use these words, that's just what it means. Now we're going to talk about how do you write an equation for a parabola or a quadratic when they give you 3 points. Now remember back at the very beginning of the year when we wrote equations for lines, you also did this in Algebra 1, you had to have at least 2 points to make a line. So you had to have at least 2 points on a graph in order to graph a line. So the same thing is going to be true for a quadratic. Instead of 2 points though, we have to have 3. So if you see here in example 1, it says a parabola contains the points 0, 0, -1, -2, and 1, 6. They give us 3 points and they want us to write an equation for the parabola in standard form. Now remember, standard form, how you write standard form, ax squared plus bx plus c. That's standard form for a parabola or a quadratic. Okay, so we're gonna use 2 different methods in order to do this. First, I'm going to show you how to do it using algebra. Okay, so what you would do using algebra is you would take this standard form, and we're going to do that for every single point, and we're going to sub in for x and y every single point. So y equals ax squared plus bx plus c. Now, what I'm going to do is I'm going to take 0, 0, and I'm going to put it in for my x and my y values. So 0 is the value for y, and 0 is the value for x. Notice now what's going to happen. That 0 on the A is going to cancel that term out, and that 0 on the B is going to cancel that term out. So all we're left with is C equals 0. So I know in my equation I'm going to have a 0 for C. Okay, so we're going to do the same now for the other 2 points. So I'm going to take -1 and -2. Oops. And I'm going to sub it in for my x and y points. Now, what do I know C is? I know C is 0. So what I'm going to do is instead of writing C, I'm going to go ahead and put in a 0. So what this leaves me with is -2 equals A because -1 squared is 1, and 1 times a is just a. B times -1 is -b. So this is one equation. Now I'm going to do my third one. So I'm going to take 1 and 6 and put it in. And then again, same thing. I know C is 0. So I'm going to go ahead and put in the 0. Now this gives me an equation of A plus B. I'm going to take both of these equations now. This is a systems problem. Remember way back last semester when we did systems. So -2 equals A minus B. I'm going to line them up. 6 equals A plus B. Now remember, what you can do is you can either use substitution or you can use elimination. I'm going to do elimination because I noticed that this one of my B's is negative and one of my B's is positive, so I can just add down and they'll cancel right out. So that's what I'm going to do. I'm going to cancel those out. This gives me 2A equals 4. What is A going to equal? We'll divide out the 2. A equals 2. So I have my A value and I now have my C value. So what I'm going to do is I'm going to use back substitution and I'm going to plug in my 2 for my A into the 6 equals A plus B, and I'm going to figure out what my B value is. So if I solve that equation, I'm going to move my 2 over, and that gives me 4 for B. Okay, so we can find the equation for a parabola using our systems knowledge. So my final answer is going to be, I'm going to take my A value, my B value, my C value, and I'm now going to plug them in, and 2x squared plus 4x plus 0, but I'm not going to put the 0. So this right here is my final answer. Okay, that's the equation that represents that parabola. So that's how you do it using algebra. So you have a few problems that are like that where you'll have to be able to use algebra in order to solve. But for the most part, when we write equations for quadratics, we're going to use the calculator way. Okay, so I put up here for you how you plug it into the calculator. So get your calculator out and let's go back and let's try to plug in these 3 values again. So you go, follow my directions. It says stat edit. So you're going to go to stat edit. And notice your L1, L2, L3 screen pops up. You're going to put in your ordered pairs. So for L1, I'm going to put in my x values, which are 0, -1, and 1. For my L2, I'm going to put in my y values. So 0, -2, and 6. Okay, so once you do that, then what you do is you hit stat one more time. You tab over to the calculator, calc button, and you choose option 5, which says quad reg, okay, quadratic regression. That is what we are trying to calculate. And you just hit enter all the way down until the blinking screen is on calculate. Then you will hit enter, and what it will do is that will actually give you the A, the B, and the C value so that you can write your equation. So that is how you're going to do it using the calculator method. Okay, so double check with these values on that example 1 and make sure before you go any further that you know that you got 2 and 4 and 0 for your A, B, and C value in your calculator. Okay, so on to example 2. It gives us a table showing a meteorologist's predicted temperatures for a summer day. What is the quadratic model for this data? So we are going to use your calculator. When they give you tables like that, use your calculator method, okay? Now, one thing to note is that we don't want to have double X values. So if you notice, it goes 6 a.m., 9 a.m., 12 p.m., 3 p.m., 6 p.m., 9 p.m. So if you notice, the 6s are repeating and also the 9s are repeating. That's not good for us to do in the calculator. How we're going to fix this is we're going to go in and we're going to edit our values. Now notice, we can leave it starting at 6 a.m., 9 a.m., 12 p.m. When we hit 3 p.m., we're going to want to change that. Think about if you were graphing that on an x-axis, you would want it to go by threes. So 6, 9, 12. I'm going to change that value to 15 just to plug it into my calculator. So then same thing with 6 p.m., add 3 to that. So that value is now going to become 18. And then 9 p.m. is going to become 21. So you can kind of adjust your table, okay? So what you're going to want to do is you're going to want to go to Stat Edit, and in L1, you're going to write 6, 9, 12, 15, 18, 21. Now, technically, you only need 3 of those values. So you could have stopped at 12 p.m. and been totally fine, okay? Because remember, you only need a minimum of 3 ordered pairs in order to make a quadratic, okay? But the more that we have, the more accurate it's going to give us. So then you're just going to go in and put your, 63, 76, 86, and so forth in your L2s, okay? So when you do that, the answer that spits out is you get an A value that equals negative 0.329. You get a B value that equals 9.798, and you get a C value that equals 15.571. So double check yourself and make sure that you got these values, okay? So then what you're going to do, part A, or the first question that it asks us is, what is a quadratic model for this data? So the answer to that will obviously be to take the values and put it into a quadratic format. So that is our A value, so ax squared plus bx plus c. Okay, so that is the answer to the first question. Now the second question says, predict the high temperature for the day. Okay, so how we're going to do that is we're actually going to take our calculators now, go to y equals, and put in the equation that you just wrote. So into y equals, you're going to put in negative 0.329x squared plus 9.798x plus 15.571. Then you're going to go to second, calculate, because we want to calculate the maximum, the high temperature, right? High temperature can go with our maximum value. So you're going to calculate the max value. You're going to have to do the left bound, right bound thing. Go on the left side of the graph, hit enter, go on the right side of the graph, hit enter, and then guess the maximum. Now, it's going to give us slightly off of, it's like 15, or it's 14.9 something and then 88.9 something. So we're going to round to 15,89. So right there, that is our max, or in the terms of the question, that is our high for the day, okay? So what it says is predict the high temperature. Now, Is 15 the high temperature or is 89 the high temperature? 89 is going to be our high temperature. So the second question, it's 89 degrees is our high. Okay? Now, at what time does this high temperature occur? Now, remember, we kind of went in and messed with our times so that it would graph it out correctly. So if you look, 15, we have 15 and it's right there. Now, what time did we mark out for 15? 3 p.m. So around 3 p.m., that was our high. That answers all three of those questions. All right, moving on to the very last one. So it says, determine whether a quadratic model exists for the values. If so, write the model. So you can get your graphing calculators out here, and you can do the stat edit, type in your 3 ordered pairs. Now remember, this looks a little bit different. The formatting, this is our, these are our x values. And these are our y values. So don't let that throw you just because it looks a little bit different than how we're used to seeing it ordered pairwise. Okay, so you're still going to take them, put your x's into L1. So L1 and L2. My L1 values are -2, 0, and 1. My L2 values are 16, 0, and 4. And calculate. Now, the key here is if you get a value for A, which is our squared term, which is what makes it a quadratic, then a quadratic model exists. So when you do this and you get your values, you get A to equal 4, B to equal 0, and C to equal, it is 0, even though it looks a little crazy. That's actually, it's just a very, very tiny, 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 tiny number, almost to 0. So we're just going to say it's 0. Y equals 4x squared. So when I write that out, do I have a number in front of my x squared term? Yes, I do. So this is the quadratic model. Okay? Now, so when you're going to do the next one, same thing. X, 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 Y, Y, Y. So in L1, you're going to write -1, 1, and 2. And for L2, you're going to write -4, -2, -1. And when you calculate and you get an answer, you get an A value of 0, a B value of 1, and a C value of -3. So if I write that out, this is what it would look like. Now, that means this term cancels out. And if my x squared term cancels out because there's no value, it's 0, it's not quadratic anymore. So in this case, our answer is no. It is not a quadratic model. And that right there, I think that takes care of all the questions that are going to be on your homework.